Okay, here's warm-up number 28. This is an older review problem. What theorem allows you to conclude that these two lines are parallel? Well, if you look at angles 1 and 2, these are in corresponding positions. They're both in the top right of their respective intersections. So these are corresponding angles, and since they're congruent, that means the tracks must be parallel. Okay, but this is not just the corresponding angles theorem. Corresponding angles theorem was if I know the tracks are parallel, then I can say the angles are congruent. So when you start with knowing something about the angles and finish with the tracks being parallel, that's going to be a converse. So this is the converse of the corresponding angles theorem. Okay. All right, and next up, write the component form. So component form, remember, that's going to look like this. It's going to look like an ordered pair, but with those funny brackets. Okay. So I'm going to write a component form of a vector that maps point A to point B. So what I want to do is think, well, how did I get from my first x value to my second x value? Okay. So I'm going to add something to that. And you can probably figure that out in your head, but let's just write this out algebraically. I'm going to add something that's going to give me the x value in here, right? So this will be whatever my x is, and this will be my y, okay? And then I'm going to do the same thing with the y's. So to get from here to here, I'm going to add something else. I'm going to add whatever my y number is going to be right there, okay? So yeah, you could probably do this in your head, but you could also write an equation. You could say 3 plus x is going to equal 6. And then I can solve this for x. So x is going to equal 3, right? Makes sense. I'm adding 3 to get from 3 to 6. And then I can do the same thing with the y's. Negative 5 plus y is going to equal 2. I would add 5 to both sides here to solve for y. And y is going to equal 7. So going from negative 5 to 2 on a number line, you'd go 7 units to the right, right? Negative 5 plus 7 is 2. So, hey, there's what goes in both slots. So 3, 7 is component form. Okay? That's different, by the way. It often gets confused with writing a rule. If we're asked to write a rule, which we're not here, but I just want to go over it anyways. A rule would look like this. It's telling you what to do to the two coordinates. It means the same thing, but this is component form, this is a rule, okay? All right, what type of transformation is equivalent to a reflection over two parallel lines? So I've got a multiple choice deal going here, okay? Let me just sketch this to, sketch two parallel lines first to try to illustrate this. All right, got two parallel lines, and I'm gonna just put an uppercase F here. Okay, and let's say I'm reflecting this. The drawing, it's not a point, it's like just actually a drawing of the letter F. Let's think about that. Okay, so if I reflected that over this first parallel line, and I'm making a really quick sketch here, but it would look something like that, right? If I reflected over that first line, okay? And then if I took this and reflected over the second line, it's going to end up something like this, okay? So then if you look at the first image, which was this one, and then the last image, and think, well, which of these would it match up with? Yeah, I reflected it twice, but I'm talking about going from the first, for the pre-image to the final image. And it's not a rotation, it's not a dilation, it hasn't changed size. What's happened is it's a translation. It's just a slide, right? It's glided down and to the right or just in that direction, okay? And then let's look what happens when we go over two intersecting lines. Okay, so hey, here's two intersecting lines, and I'll use the letter F again. Okay, so I'll start with my F up here this time. If I reflect over this vertical line, it's going to look something like this, right? It's going to kind of just flip around like that. And then if I reflect over this second line from here, it's going to look something like that. Okay, so let's ignore the middle one. We're just looking at these two. So this is my original, right? And that's the final one. And then we can decide which one it is, and hopefully you can see that that would be a rotation because it's kind of turned. Some people might choose reflection, but it's not a reflection. You can reflect it and have it over just a single line and have it look like that. It wouldn't work out like that actually, but it will work if you rotate around the center and kind of twist it around upside down like that. Okay, so this one's going to be a rotation. That's what happens when you reflect over two intersecting lines. Okay, and that's it for this warm-up. See you next time.